Hello friends, welcome to Expert Guidance. Today in this video, we'll be covering the topic of forces of GCSE Physics. Now this is a very important topic because in this unit, we'll be covering both forces and the motion topic. And both of these topics are very important for your GCSE Physics. So I would request you to watch the videos till the end because we'll be covering each and every topic in detail, followed by the glossaries and the key terms of this unit. So let's begin. Now in this unit, we'll be covering the topic of forces in motion, and we'll be covering what are scalars and vector quantities, what are the contact and non-contact forces, what is gravity, what are resultant forces, how do we work out the resultant forces, the concept of work done and energy transfer, forces and elasticity, moment levers in gas, pressure in a fluid, atmospheric pressure. And for motion, we'll be covering all the Newton's law of motion, Newton's first law, second law, third law. We'll be covering forces in braking, the braking distance, the thinking distance, and the reaction time. We'll be covering the distance, displacement, speed, velocity, acceleration, the distance time graph, velocity time graph, momentum, and the conservation of momentum. So let's begin. Now, the first thing that you need to remember is what are scalars and vector quantities. We need to know the definitions of them and few examples of them. Now, in the exam, they can ask you as a normal question, what are scalar quantities? Give example. What are vector quantities? Give examples. Or they can give you different quantities and ask you to classify them in scalars and vectors. So you should know what are scalar quantities and what are vector quantities. Now, scalar quantities are those quantities that has magnitude only. They do not have directions. Whereas vector quantities, they have both magnitude as well as directions. The examples of scalar quantities are length, area, volume, temperature, speed, mass, density, pressure, work, energy, power. All these are the scalar quantities. The vector quantities are displacement, velocity, acceleration, momentum, force, weight, drag, and thrust. So again, scalar quantity has magnitude only, but no direction, whereas vector quantities has both magnitude as well as direction. So like speed and velocity. Speed is just the magnitude, so it's a scalar quantity. Velocity is the speed in a given direction, so that becomes the vector quantity. Okay, now let's see what is the distance and displacement. So let's focus on this figure here. If suppose I went from this point, I went all the way to this, and reach here. So the whole distance will be my total path taken. But what would be my displacement? My displacement would be just this distance. That is the distance between the starting and the initial point. No matter whether I go there directly or I take multiple routes, the distance between the initial and the final point will be a displacement, and distance will be the total path taken. Also, distance is a scalar quantity and displacement is a vector quantity. Okay, and displacement is the distance with the direction. Okay, so I hope this concept of distance and displacement is clear to you. Now let's come to forces. Now, what is a force? If I push or pull something, is that a force? No. So forces push or pull on something that will either change the speed or the direction or the shape of the object. So force is a push or pull on an object that causes an object to change speed, direction, and the shape. I hope you're clear with what are forces. Now let's see what are contact and non-contact forces. Now, contact forces are the force experienced by the body when there's physical contact, like friction. How does a friction happen? When two objects are in close contact to each other. The air resistance, drag force, the tension, these are all the contact forces. On the other hand, non-contact forces are the force experienced by the body without any physical contact. For example, the gravitational force. So if the earth is pulling something towards itself, there's no contact. but the force is still acting. The same thing goes for electrostatic forces and the magnetic forces. So you should know the definitions of contact and non-contact forces and the examples of them. Now let's move on to a friction force. Now what is a friction? Friction is a contact force we just discussed, and that opposes the motion between the two surfaces that are in physical contact. So friction always happens in the opposite direction of motion, and it is a resistive force. Now, is friction bad? Well, not necessarily. It's a necessary evil. Friction is bad in most of the cases. It causes wear and tear of the machines. It can cause wear and tears of the tires. But if the friction is not there, the vehicles can slide, because it's the friction that prevents the vehicle to slide because of the friction between the tires and the roads. It is a friction that helps us to light a matchstick. So frictions has both its advantages and disadvantages. Now let's see what is the Newton's third law of motion first. Now Newton's third law of motion says that for every action force, there is an equal and opposite reaction force. That is the force acting in pairs. So you can take an example of these two skaters. The skater move towards each other as they pull on each other with equal and the opposite force. If you push a brick wall, the wall will push back to you with an equal and opposite force. Okay, so that is Newton's third law of motion. Now let's try to understand the concept of resultant forces. What are resultant forces? Now let us take a look at these two diagrams. What is happening in these three diagrams rather? In the first one, I have a 60 Newton force and a 30 Newton force, both acting in the same direction. They'll add up and the total force will be 90 Newtons to the right. So the object will always move in the direction of the resultant force. In this case, the object will move towards the right. Now let's look at the second case. In the second case, I have 30 Newton force to the right, but 10 Newtons to the left. Now, since both the forces are acting in the opposite direction, they have opposite effect. The net force in this case will be 30 minus 10, which is 20 Newtons effective to the right. So in this case, the body still moves to the right, but the force acting on this body is not 30, not 10. The net force is 20 Newtons. In the third case, I have 30 Newtons to the left and 30 Newtons to the right. So both the forces are equal and opposite. So the body will experience no force overall. This case is known as the balanced force. And in this case, the body will stay at rest if it is at rest, or if it is moving, it will continue to move with the same speed. Okay, so this is the concept of resultant force. Now, what is a resultant force? It is the total force that acts on the body. It is the sum of all the forces that acts on the body. The resultant force will decide what will be the speed and direction of the body. The resultant force could be balanced. Balanced is this case 3, where the resultant force is 0. If the forces are balanced, the body is at rest, then it will stay at rest. And if the forces are balanced and the body is moving, it will keep on moving with the same speed and direction. Whereas unbalanced forces is the case 1 and 2, where the net forces are not 0 and the body will move in the direction of the resultant forces. I hope now that the concept of resultant and the balanced and the unbalanced forces is clear to you. Now let's see that this concept can help us to explain the Newton's first law of motion. Now the Newton's first law of motion says that, as we just discussed, if the object is at rest, it will remain at rest. And if the object is in motion, it will continue to move with the same speed and direction unless no resultant force acts on it. So if the resultant force is non-zero or unbalanced, the object will move or change the speed and the direction. So let us see in this case. In this case, I have one forces to the right and the other big forces at the right, 2 forces at the left. This is unbalanced forces in the same direction. In the second one, I have the forces acting in the opposite directions. So that is unbalanced force in the opposite direction. And in the third case, both the case forces are equal and opposite. So that is a balanced force, and the object experiences no net force. Okay, now I hope Newton's first law, which is the concept of balanced forces, and Newton's third law, which is action-reaction pairs, is clear to you. Now the next thing is moment. Now moment is a very important concept. There are a lot of questions that are asked in the exam on moments. What are moments? Moment is a turning effect of force, and moment is given by the force times the perpendicular distance from the pivot. Okay, now greater the distance from the pivot, for example, if you have a long axe, the moment or the turning effect will be greater. So just increasing the distance from the pivot can increase the moment, and it can help to lift a heavy load. So if you see this example of a crowbar, the pivot is here and we increase the distance from the pivot. So the effort is at a greater distance, so that it increases the moment so it can lift a heavy load. Okay, so there are a lot of moment questions that are asked in the exam. So you can take a look at this example. The first one is calculate the moment. The distance from the pivot is 10 meters. The force is 30 newtons. So we do force times the distance. Remember, it's the perpendicular distance from the pivot. So 30 times 10, 300 Newton meters is the moment in this case. In the second case, they have given you the moment and they have given you the distance and asked you to work out the force. So we can have the help of this triangle. That moment is force times distance. So the force will be moment divided by distance. My moment is 50 Newton meters. The distance is 10. So the force is 5 newtons. Now please take care of the units here. The forces has to be newtons and distance has to be meters. In the exam, they give you the centimeter units, and the students turn up using the same formula without converting the units to meter, and then they lose marks. So make sure that you take care of the units. Now, what are levers and gears? Levers are basically the turning effect of the force is done greater by increasing the distance of the effort further away from the pivot. It increases the turning effect and it multiplies the force with a small effort. So bottle openers, panners, and scissors are the examples of some of the simple levers. And what are gears? Gears transmit the turning effect of force. Now what happens in gears? We have gear A and gear B. The gear A is connected to the engines and it has a small radius, whereas the gear B has a bigger radius and it is connected to the wheels, right? At this point, they exert an equal and an opposite force. Now, what happens? The turning effect is greater due to a greater radius. Now, gears are of two types, the low gear and a high gear. The low gear have a low speed but a high turning effect, whereas high gear has a high speed and low turning effect. Okay, so what is speed? Now we are learning since key stages in our primary. Speed is distance over time, and speed is the scalar quantity. Velocity is a vector quantity. Velocity is the speed in a given direction. And if the speed is in meters per second, then the distance is meters times in second. We can rearrange this triangle to find the distance. We can do speed times time. Now, what is acceleration? Acceleration is change in speed over time. Now, what is change in speed? It is the final velocity, which is v, take away the initial velocity, which is u, divided by the time. Remember, the time has to be in seconds. Okay, so these are the two important triangles you need to remember with the units, and you can also use this triangle to define these quantities if asked in the exam. So what is speed? Speed is distance over time. What is distance? It is speed into time. What is acceleration? It is change in speed over time. And how do you work out the change in speed? We do final velocity minus the initial velocity. Okay, now if you're clear with this triangle, try these two questions. A car is traveling at the speed of 20 meters per second. Calculate the distance covered in 10 minutes. And second, a body is traveling at 20 meters per second. Come to rest in 1 minute. Calculate the acceleration. So you can pause the video, have a go at these questions, and then come back to check the answers. All right, now let's look at for the first question. They have given you the speed and the time is in minutes. But our triangle says that the time has to be in seconds. So we times 10 by 60 to get the time in seconds. And the formula is distance is speed into time. So we do 20 meters per second times 10 times 60, and we will get the distance of 1200 meters. For the acceleration questions, we know acceleration is final velocity minus initial velocity over time. In this case, the body comes to rest. It means it has finally stopped. So my final velocity will be 0. Take away the initial velocity, which is 20 meters per second over the time. Time is 1 minute, which is 60 seconds. So minus 20 over 60 is minus 0.33 meters per second square. And here again, the time was in minutes, so we have converted it into 60 seconds. Okay, so you should have a go at different rearranging questions on how you can use these triangles, as it is a very important topic. Now, they can ask you to work out the distance or the speed graphically as well. Okay, so graphically as well, we have to use the distance time graph. Now, what is a distance time graph? In the distance time graph, we have distance on the y-axis and times on the x-axis. Now, if the distance times graph gives a straight line passing through the origin, it means that the object is covering equal distance in equal time, so it is moving with a uniform speed. If the distance cover, so you can see at this part, the distance cover remains the same. It's not changing with a change in time. It means that the object is not moving, it is at rest. But if the distance is decreasing with time, it means it is returning to the start. Okay, so in the exam, they can give you the graph and ask you, what does this graph show? So you have to look at it. Remember, you need to look at the axes, because if it is a velocity time graph and you see a straight line, the horizontal straight line, that does not move. That does not mean that the body is not moving. But if the distance time graph is flat with no change in distance, it means that the body is rest. So make sure you read the axes correctly. So if in the distance time graph, if you have a straight line passing through the origin, it means that the body is moving with uniform speed. If you have the horizontal, it means that the body is not moving. And if you have the distance going down, it means it is returning to the start position. And the slope of the distance time graph gives you speed. This is also a very important thing to remember, because in the graph, if they ask you to find the speed, we'll be finding the gradient of the line. How do you work out the gradient of the line? You take the difference between any two y points divided by the distance between the x points to work out the gradient. Okay, so now we will have a look at a distance time graph question, and we'll see how we'll work that out. Okay, so we will have a look at this question where we need to calculate the speed from 0 to 6 seconds, that is the straight part of the graph. Calculate the speed at 6 to 11 seconds, that is this part of the graph, and 11 to 17 seconds. Okay, so you can have a go at this, pause the video, and then come back to check the answer. Now from 0 to 6 seconds, we'll work out the gradient of this line. So we can take this point, which is 10 minus 0, divided by these corresponding x points, which are 6 minus 0. So that gives 10 over 6, which is 1.6 meters per second. From 6 to 11 seconds, there's no change in distance, so that part is 0, so the speed is 0. Now from 11 to 17 seconds, we can assume this to be an ideally straight line, and we can work out the gradient by doing 10 minus 2 over the 11 minus 7, which is minus 6. So it will come out to be 1.3 meters per second. Okay, so it is slowing down with the speed of 1.3 meters per second. Okay, so I hope this distance time graph is clear to you. Now let us look at the velocity time graph. In the velocity time graph, O to A means that the body is changing velocity but with the same rate. So it means that the body is moving, in this case, with constant acceleration or uniform acceleration. So there's a constant acceleration or uniform acceleration in this part of the graph because it is the velocity time graph. From A to B, there is no acceleration because the velocity is not changing. Now, that does not mean that the body is not moving. The body is moving, but with the same velocity, so it has no acceleration. And from B to C, the velocity is decreasing with time, so this is deceleration. Now, the slope of the velocity time graph gives you acceleration. We've just seen a question, how do we work out the acceleration from O to A? And if you work out the area under the graph of the velocity time graph, you get the distance. Okay, so you need to remember these two things. Now let's try a question. So you need to calculate the acceleration from O to A and A to B. So you can pause the video and try this and come back to check the answer. So from O to A, we will do 10 minus 0 divided by 6, which is 1.6 meters per second square. And from A to B, since there's no change in velocity, the change in velocity is 0. So the acceleration in this part will be 0. Okay, now let us see the equations of motion. Now, there are two equations of motion. V equals u plus at. V stands for final velocity, u stands for initial velocity, a stands for acceleration, t stands for time. You can use this equation if you have any of the three things and you are asked to find the fourth thing, which is unknown, or if they give you just the final velocity, initial velocity, and acceleration and distance but no time, then we can use this another equation, which is v square minus u square is 2as. So you can remember these two equations, and then you can try these questions, which is at the right. You have to calculate the final velocity when the body is at rest, accelerates to 10 meters per second square in 20 seconds. And for the next question, you have to calculate the distance traveled when the body is moving at 5 meters per second, accelerates to 10 meters per second with the acceleration of 5 meters per second square. So you can pause the video, have a go at these questions, and come back to check the answer. Now, for the first question, our final velocity, we have to work out, and the body starts from rest, so u becomes 0, acceleration is 10, t is 20. So that means we can use this first equation, v equals u plus 80. So final velocity would be initial velocity, which is 0, and a times t is 200. So it means that the final velocity is 200 meters per second. For the second question, they have given you u, that is the body starts from 5 meters per second. The final velocity is 10, acceleration is 5 meters per second squared, and you have to calculate the distance. So we can use the equation v square minus u square divided by 2as. So v square, so if you rearrange this, distance is v square minus u square over 2a. So that is 100 minus 25 over 10, which gives us a distance of 7.5 meters. So in the exam, they can give you different values and ask you to work out the unknown. So make sure you remember both of these equations of motion. This is very, very important. So now let us come to the Newton's second law of motion. The Newton's second law of motion. So now the Newton's second law of motion says that the acceleration of the body is directly proportional to the force, and the acceleration of the body is inversely proportional to 1 over the mass, which means that acceleration is force over a mass. So we can arrange this as force is equal to mass into acceleration. Okay, so this is what is the concept of Newton's second law of motion. And in the exam, they can ask you to work out force, mass, or acceleration by giving you any of the two quantities. Okay, so we can take an example. Calculate the acceleration of the body of the mass 10 kgs falling downwards with a force of 50 newtons. Okay, so we can use this formula that acceleration is force over a mass, and my force is 50 newtons and my mass is 10 kgs. So it means my acceleration will come to 5 meters per second squared. All right. Now let us come to what does the Newton's second law of motion we can interpret is force is mass into acceleration. So if something is speeding up, it means that the velocity of the object is increasing, the object is accelerated. It means that the resultant force is in the direction of the motion. But if something is speeding down, it means that the velocity is decreasing, the object is decelerated, and the resultant force is in the opposite direction to the direction of the forces. Now let us take a look at a very important concept, which is weight and terminal velocity. Now you must have heard what is your weight. Now what exactly is this weight? The weight is the force acting on the body due to gravity. The mass and weight are different. Mass is nothing, but it is the amount of matter in an object. So no matter whether you are on the Earth, in the Moon, or any planet, the mass of the object will remain the same. But the weight will not be the same because the gravity is different in all this, and weight is the product of mass times the gravitational field strength. So the first difference between mass and weight is that the mass is the measurement of amount of matter in an object, whereas weight is the force acting on the body due to gravity. The mass is measured in kgs, the weight is measured in newtons. Mass is always constant, weight is variable as it changes with gravity. Mass is a scalar quantity, weight is a vector quantity, and you measure the mass by beam balance and you measure the weight by Newton meter. So this is the formula. Weight in newtons is mass in kilograms times gravitational field strength, which is Newton per kg. All right, so now let's take an example. You have to calculate the weight of the object of mass 10 kgs. Remember, on the Earth, if they don't give you in the exam, you can use any of the values, 10 or 9.8. If they specify, use this value, then you will use that value. Then calculate the gravitational field strength of the same body of the moon if it weighs 16 newtons and more. So have a look at, try out this question, pause and come back. For the first question, weight is mass times acceleration, so 10 times 10, which is 100 newtons. For the second one, if we rearrange this formula, the gravitational field strength is weight divided by mass. The weight is 16 newton. The mass of this object originally was 10 kgs. So 16 over 10 is 1.6 meters per second square is the acceleration on the moon. So you have to remember this expression and how you have to rearrange it to work out your answer. Okay, now what is the relationship between work done and force? Work done is force times the distance, and work done is also equal to energy transferred. Now there are two questions which you can try where you have to calculate the work done when the force is 100 newtons. It moves an object by 2 meters. And in the second case, the force applied when 100 joules of work is done to move a distance of 5 meters. So you can pause the video and try this question. For the first one, force will be, the work done will be force times distance, which is 100 times 2, which is 200 joules. For the second question, the force is work done over distance, which is 100 over 5, which is 20 newtons. Okay, so I hope this force and the work relationship is clear to you, and what is the difference between the mass and the weight. And next we will be talking through the concept of terminal velocity, which is a very important concept. So have a look at it now. Now let us move on to a very important concept of terminal velocity. Now what is terminal velocity? So terminal velocity is the constant velocity of an object when the resultant force is 0 and the weight of the body is balanced by the drag and the body has 0 acceleration and it falls with a constant speed. Looks confusing? Let us understand this with an example. So if you look at here, I have dropped a ball from a height. So it's a free fall and the weight of the body is 1 kg. So the downward force, the weight force is 10 newtons. Now, as the body falls a little distance, the air resistance starts to build up. So here, 10 newtons is the downward force, 3 newton is the resistance. So the net force acting on this body is 7 newton downwards and it will accelerate downwards. After a little distance, the air resistance keeps on increasing and it increases to 7 newtons. The downward force is 10 newtons. Again, in this case as well, there is the resultant force acting, which is 10 minus 7, 3 newton downwards. And since the resultant force is acting on it, the body will accelerate in the direction of the resultant force. So the body will accelerate downwards. But after that, there will come a point where the air resistance is also 10 newtons and that will balance the weight. So resultant force acting on the body is 0. And when the resultant force is 0, the body has no acceleration. Acceleration is 0. It falls with a constant velocity. And that is what is a terminal velocity. So this situation here, where the weight of the body is balanced by the drag, resultant force is 0, acceleration is 0, and the body falls with the constant velocity is terminal velocity. So you can see here in the graph that the velocity is increasing, it means that the body is accelerating. But after some time, it comes to constant velocity, and that constant velocity is termed as terminal velocity. Now, terminal velocity is also seen in the fluids. In the fluids, when you drop something in water, the weight of the object is balanced by the frictional force acting upwards. The body falls with constant velocity as no net force or resultant force acts on the object. So the body falls at constant velocity called the terminal velocity. So this concept is also seen in fluids. Now let us look at forces and braking. Now what is forces and braking? When you're driving a car and you see some object coming in front of you, you first think what it is, then you apply the brake. Now, as soon as you apply the brake, the distance your body has traveled after applying the brake is the braking distance, and the time it has thought that you have taken to think and apply the brake, that is thinking distance, and together both of this distance, thinking and the braking distance, constitute the stopping distance. So the stopping distance is the shorter distance of a vehicle can safely stop in. It is the sum of the thinking distance and the braking distance. Thinking distance is the distance traveled by the body during its reaction time, the distance traveled when you're thinking, and it is calculated by speed into reaction time, and it can be affected by tiredness, drugs, alcohols. Whereas braking distance is the distance traveled by the body when the brake force is applied, and the factors that can affect it are poor weather conditions, road conditions, poorly maintained vehicles, speed of the vehicles, and the mass of the vehicle. Now, this question can come in the exam. What affects the thinking distance? What affects the braking distance? What is the stopping distance? So you should know about that. Now, let us come to a very important concept called momentum. Now, what is momentum? Now, let's look over the momentum concept. Now, what is momentum? The momentum is the product of mass times velocity, and since momentum involves velocity, it is a vector quantity. So it has magnitude as well as direction, and momentum depends on mass and velocity. So greater the speed, greater the momentum, higher the velocity, higher the momentum. And the unit for mass is kilogram, velocity is meters per second, so momentum is given by kilogram meters per second. Now, in the exam, they can give you the masses and velocity, ask you to find the momentum, or give you the momentum and ask you to find the velocity. And there's a very important concept of conservation of momentum. Now, what is conservation of momentum? It states that in a closed system, the momentum before the collision and after the collision remains unchanged. So m1v1 is equal to m2v2. Now, let's see how we can use that with an example. So here comes a question that there's an object of mass 100 kg which is moving with the speed of 10 meters per second. So you have one body which is moving at 10 meters per second and it collided with another body of mass 220 kg and it at rest. And after collision, they started to move together, and you need to calculate the speed after the collision. So have a try at this question. Work out the momentum of both the bodies before the collision. That should be equal to the momentum after the collision, and you can use that to work out the speed. Now let us look at it. Now before collision, we know that the mass of object 1 is 100 kg, velocity is 10. So the momentum of the body 1 is 100 times 10. But for the other body, since it is at rest, the momentum would be 0. So the total momentum before collision is 1000 kilogram meters per second. Now, after the collision, they both stuck together and moved together. So the total mass now would be 120 kgs, 100 plus 20, but we don't know the new velocity. So let us take that as V. So the momentum after the collision would be 120 times V, which should be equal to the momentum before collision, which is 1000. So we would be 1000 over 120, which is 8.33 meters per second. So this is how we do these questions, where you calculate the momentum before the collision and after the collision and use them to find the unknown velocity. Now there's another concept called the impact forces. So the force is the change in momentum over time. So that is another definition for force. Now, change in momentum would be V is the final velocity, U is the initial velocity, then mv minus mu over t gives change in momentum, So mass equals V minus U over T, where V minus U is acceleration. So that derives force is equal to mass into acceleration. Now, if we increase the time and the moment is conserved, the momentum is conserved, the impact force can be decreased. So greater impact time is a reduced impact force. So this can be used in a lot of safety features. So in the car safety features, we have the seat belts, airbags, and crumple zone. All these features increases the impact time, so that decreases the momentum and thus reduces the impact forces. So when we wear the seat belts, they spread across the person's body and increases the impact time, which decreases the decelerating force. The airbag also spreads the force, increases the impact time, decreases the impact force, minimizing the injuries. And the crumple zone also increases the impact time, which changes the momentum of the passengers. As the time is increased, the impact force is decreased. Because force is change in momentum over time. If you increase the time, then the force will go down, and that will prevent you from getting the injuries. Now let us move on to the relationship between the forces and the elasticity. Now we know when we apply a force to any object, it can either move or come to rest. But there's a third thing that can a force do. It can either change the shape of the object. So it can cause bending, stretching, and compressing of an object. Now, the compressing or deformation could be elastic. So when the force is removed, the object regains its original shape. That kind of deformation is known as elastic deformation. And inelastic deformation is that the object does not gain its original shape and it changes shape permanently after the force is applied. Example, overly stretched limit. Now let us see what is the relationship between the force and the elasticity. Now let us see what is the relationship between the force and elasticity. Now there was a scientist called Hooke's, and he gave a Hooke's law. He said that when you apply force to a spring object or any elastic object, as you keep on increasing the force, it will keep on extending. So the force you applied will be directly proportional to the extension. If you double the force, the extension produced in the spring would also be double. So we can write this expression as force is directly proportional to x. And to convert the proportionality sign into equal to sign, we can introduce a k, which is an elastic, the Springs constant. So that becomes force equals kx, which means as we increase the force, the extension is increasing, and this is the graph which shows a spring obeying the Hooke's law. And we can use this triangle, force is equal to K times E, where force is given in newtons, the spring constant is given in newtons meters, and extensions is in meters. Now you can see that there is a little curve and the flattening of the graph here, and this is the point which is limit of proportionality or the elastic limit. Now at this point, the body has lost its elasticity, and after this, it will not obey the Hooke's law and it will not come back to its original shape. So Hooke's law is only obeyed until the elastic limit of the object is reached. And this is what you need to remember, that force is directly proportional to extension up to the limit of proportionality or the elastic limit. Okay, so now we can rearrange this. Springs constant could be given by force over the extension. So if they have given you force and extension in the question, you can divide the two to get the spring constant. And what is the limit of proportionality? It is the point up to which the spring obeys Hooke's law. Beyond this point, the object comes in plastic region and no longer obeys the Hooke's law. Okay, now let us look at two examples. First is calculate the force applied in the spring where it is extended by 2 meters and the spring constant is given to you. And in the second question, they ask you to work out the spring constant when the force is 50 newtons and the spring is extended by 5 meters. Now remember to take care of the units, that the distance has to be in meters in all of them. Okay, so pause this video, have a go at this question and come back to check the answers. So for the first one, we can use force equals KE. Our spring constant is 5, extension is 2, so the force becomes 10 newtons. And for K, we'll do force over the extension. Force is 50 newtons, extension is 5 meters, so our spring constant is 10 newtons per meter. Now, As you know that all elastic object, the forces applied, then they also have elastic potential energy stored in them. And the formula to calculate these elastic potential energies half KE squared, where E is the elastic potential energy, which is measured in joules, K is the spring constant given in newtons per meter, and E is the extension of the spring in meters. And elastic potential energy is the energy stored in the spring when it is stretched or compressed. Okay, so now you have 2 questions on the board to calculate the elastic potential energy when the spring constant is given to you and its stretch is given to you. And in question number 2, they have given you the elastic potential energy and the spring constant and ask you to work out the extension. So you have to rearrange this formula. So have a go at these questions and come back to check the answers. Okay, so for the first one, we'll use this formula. Elastic potential energy is half KE squared, and we'll take care that here the distance is in 20 centimeter. We need to convert it into meters, which is 0.2. So extension would be half KE squared, which is half times 2 times 0.2 times 0.2, which is 0.04 joules. For the second question, energy, which is 10 joule, is 0.5 times 5E squared. We will take multiply this by 2, divide by 2, so E squared equals 5, E is root 4, so E would be 2 meters, so extension to joules would be 2 meters. Now, what is the relationship? What are the forces acts when the body sinks and float? So when something is sinking, then there is a weight acting downwards and the upthrust acting upwards. Upthrust is the upward force experienced by an object when it is submerged in water due to the pressure at the depth. Floating is when the weight of an object is balanced by the upthrust, and sinking is when the weight is greater than the upthrust, the object sinks. So in this case here, the weight is more than the upthrust, the body is sinking. Here it is floating because upthrust and weight are balanced, and here it is the upthrust is more, so the upward force is more. Now let us move on to a very important concept of pressure. Pressure is measured in pascals, and that is given by the formula force per unit area, where force is in Newton, area is in meter square, pressure is in Pascal. When we have greater force, we have greater pressure. Smaller the area, more will be the pressure exerted. Okay, now let us look at 2 examples. In the first question, you can look on the board. They have given you the force of 10 newtons in the area of 2 centimeter squares and ask you to find the pressure. And in the second question, they have given you the pressure of 100 kilopascals and the area of 4 centimeters squared and ask you to find the force. Now you can try these questions, pause this video and take care of the units here. The area is given in centimeters and you need to convert it into meters. Okay, so let us have a look. So for the first question, we do force over an area. Force is 10 Newton and area 2 centimeter is 2 times 0.01 squared. And the pressure would be 50,000 Pascal. For the second question, the 100 kilopascals would be 100 times 10 power 3 pascals times by the area, which is 4 meters. And centimeter square, to convert it into meter square, we need to divide it by 10 to the power 4. And when we do that, we'll get the answer 40 Newton. So I hope this is clear to you. Now, when we talk about the pressure in the liquid, it increases with the depth. The weight of the column above exerts the pressure downwards, and the pressure in the liquid is measured in Pascal, and it is given by the formula H rho G. H is the height of the column, rho is the density of the liquid, which is in kilogram per meter cube, and G is the gravitational field strength, which is newtons per kg. Height is in meter, pressure is in pascals, and G again you can use 9.8 meters per second squared or 10. Depending on if it's not given to you, you can use any of this value. Now we have something called atmospheric pressure. Atmospheric pressure arises due to the collision of the air particles in the Earth's surface, and it decreases with altitude as the number of particles decreases with height, causing decrease in weight. So if you look at the graph here, the atmospheric pressure goes down with the altitude. Okay, so I hope this unit is clear to you. And these are the important key terms that you should be able to answer. What are forces, scalar, vector, frictions, Newton's first law, second law, third law, the resultant force, what is free body diagram, moment, lever, gas, center of mass, speed, velocity, acceleration, weight, terminal velocity, thinking distance, braking distance, momentum, collisions, and Hooke's law. And we have discussed all of them in this entire video. Just to summarize, force is a push or pull on an object that causes an object due to an interaction with other object and causes an object to change speed, direction, or shape. Scalar is a quantity that has magnitude only, like length, area, and volume. Vector is a quantity that has magnitude as well as direction. Example, displacement, velocity, acceleration, momentum. Friction is a contact force that opposes the motion between the two surfaces that are in physical contact. Newton's first law says that if an object is at rest, it will remain at rest, or if it is in motion, it will keep on moving with the same speed and direction unless no resultant force acts on it. Newton's second law is force equals mass into acceleration, which says acceleration of a body is directly proportional to resultant force and inversely proportional to mass of an object. And Newton's third law says that for every action force is an equal and opposite reaction force. Then what is a resultant force? Resultant force is the total force that acts on the body. It is the sum of all the forces that acts on the body, and it is what that decides what will be the speed and direction of the body. Free body diagrams are the graphical illustration to represent all the forces acting on a body. Moment is nothing but the turning effect, and it is calculated by force times the perpendicular distance across the pivot. Weight is the force acting on the body due to gravity. Levers are which transmit the turning effect of force, and it is greater by increasing the distance of effort further away from the pivot. It increases the turning effect and multiply the force with a small effort. Gears transmit the turning effect of forces. Center of mass is the point where the entire mass of the object can be thought to be concentrated. Speed is distance over time. Velocity is speed in a given direction. And acceleration is change of speed over time. Terminal velocity is the constant velocity of an object when the resultant force is zero and the weight of the body is balanced by the drag and body has zero acceleration. Thinking distance is the distance traveled by the body during its reaction time. Now, the braking distance is the distance traveled by the body when the brake force is applied. Momentum is the product of mass and velocity. We did conservation of momentum, which states that in a closed system, the momentum before the collision and after the collision remains unchanged. And we did the Hooke's law, where it says force on a spring is directly proportional to the extension until it reaches the limit of proportionality. So I hope this unit is clear to you. As always, our next step would be that you need to check the specification to make sure everything is covered, and then you need to do the exam questions on this topic. The link is mentioned in the description box below. You can click and try the exam questions on this topic. Don't forget to subscribe to my channel and click on the bell icon so that you get notified whenever I make new videos, because I make lots of videos during the exam time. And do not forget to join my free Facebook group. It says Get a Grade 9 in GCSE Science and Maths by Mahima Laroya, where you can join and get daily tips of tips and tricks for your exams. And do not forget to follow me on Instagram at Expert Guidance or hashtag Mahima Laroya. And I also have a lot of free GCSE revision plans, a lot of free GCSE 15 weeks revision course, which you can sign up on my website. So I hope you enjoyed this video, and I'll see you next in the next video. Till then,